Hello and welcome to another video, and today I will show you how to implement this day-night cycle that I implemented for my video game. It is a very simple effect, but I think it really brings a lot of life into this game, and it is actually very simple to implement, and it is applicable for pretty much every game engine as long as you know how to adjust the lighting. So in order to adjust lighting in Godot, you will first add a canvas modulate, which has this color property with which, as you can see, you can adjust the overall color of the scene. But as you can see, there's one issue. The background doesn't seem to be affected. So for that, we simply, on the parallax layer, here you would simply adjust the modulate to set the background in correspondence to the color of our canvas modulate. So in code, we would simply fetch all the different backgrounds, as you can see here, and we would apply the canvas mod.color to their modulate. Additionally, I also added a night sky that you can see here in the background, which will become more visible the more night there is. Correspondingly, the default background will become less transparent. This is the overall idea, but now we have to get our color by time. Therefore, I have this method in this class, get color by time. First, we have a vector3, which stores our color, RGB, and then we will adjust these colors. Our first variable is daytime. How much day should there be? To get this curve, we will simply head into our internet browser. And now I am on a site called GeoGebra, and here we can simply map out a few graphs. As a baseline, we have this time value, which is always going to be in between 0 and 1. 0 and 1 being midnight and 0.5 being midday. So on the x-axis, we will have our time, which is going to be between 0 and 1. And on the y-axis, also between 0 and 1, we want to have how much day should there be. So we create a function d, which is going to be a sine wave of t times pi. So now we have one sine wave a day. Here I simply mapped out our area. We want our maximum to be at 0.5. So we can see, all right, this should move over there. So we should only have half a sine wave each day. So we simply remove the times 2, and we see we have half a sine wave each day. So when we are here, our day is the brightest, and when we are here or here, our day is the darkest. So this would explain the first line here. So if you're wondering why I've rounded it all with math_power, it is because I may want to make some adjustments, because if we make it, for example, to the power of 2, you can see that there's a slightly different course of day, but for now I stick with to the power of 1 as the first parameter of our math_power. We simply have our sine wave of the time multiplied with math_pi, just as we had it with here. You can express every mathematical expression in code just like that. So next we have a red hue. So this is the yellowish hue that comes into play. So as sun rises and sun sets. So for that we create a new graph y, and let's first map out where it should be the strongest. It should be the strongest around here and around here. Those are going to be our sunsets and sunrises. So we have to find a wave that would fit into this pattern. So it should, well, look something like that. So for that, I would use a cosine. Let's check out t times pi. Over here and down here, we would just put it to the power of 2. And now all we have to do is basically condense it a little bit. For that, we will start by multiplying it with 1.6. And now we have to move it over here. We'll have to subtract 0.2 from t, insert the rest again. Now we can see we slightly missed it here. It's actually a little bit closer to 0.68. We get quite a lot closer to this. Now we have it rather accurately. But in my opinion, it simply goes down way too slowly. We can see that in the middle of the night there would still be like this reddish hue, and we don't want this. So we simply increase the incrementation of our graph by increasing our power. For that we change it to the power of 8, and as you can see it's much better now. It starts roughly at 0 and ends roughly at 1, and then goes up rather rapidly. And it also goes down rapidly, so that throughout the day it's more like a clean color and not this reddish hue, which only should be at sunsets and sunrises. So this explains this line. We say after power, our cosine, 1.6 I have here, 1.68 would be more accurate as we found out, times pi times time minus 0.2f to the power of 8. And lastly, we also want a blue hue, which is going to be in the middle of the night to make the night a little bit more visible. So for that I created this method, as the blue hue coincides with the night sky transparency value. So let's look into how we do this. So we want the opposite of the daytime graph, so to say. So we start by making a night, we make a cosine, and a cosine in this case is of course moved by 0.5 to the left. And if we zoom out now, you can see that we have this point down here which coincides with our point B over here, and we simply raise it to the power of 2, and you can see we have our maximums over here and here. We have our maximums at midnight, which we want to have. We want a blue hue, and we have our minimum at midday. There's too much overlap with the day. As you can see, we don't want this blue hue throughout the day, so we increase the power. I used 24, as now it's basically only visible when it's dark. You can see that. So and we have the same here. We have cosine of time times math to pi to the power of 24. So we simply have this method right here which progresses our time. So we simply say time plus equals the speed of the time increase times delta, so that we have a rather constant increase. And if time is larger than equals 1, we will set it back to 0. And we also return the time in case you want to fire some events based on the daytime. We also have to multiply our colors vector with our daytime. We also add x and y, which are r and g, which together make yellow. We add our red hue with a little bit lighter weight, so it's not too visible. And we add to our blue value our blue hue in a very light manner. We don't want to overdo this. And the result is then the resulting color. So we create a new color and apply each of these values of the vector to the color. We then apply the color to our canvas mod, which then the modulates are applied to. And we also get the night sky transparency value to adjust the transparency of our two backgrounds. So the default sky is going to be, well, the night sky transparency value reversed. When it's the middle of the night, this would mean that like get night sky transparency value would be 1, so therefore 1 minus this would mean 0, and vice versa. If this is 0, then the result would be 1. We apply this to our day sky, and our night sky is going to be opposite the night sky transparency value to the night sky. And that way we created a very easy way to make a day-night cycle possible. There's actually quite a lot of possibilities using just normal maths. Like you can curve out a lot of things, some animations and well, this day-night cycle of course, and other routines in the game, probabilities and whatnot. I think it is very useful to use a graphing tool like GeoGebra to visualize what you actually want to make, how much money you make after each mission, for example. You can apply all these variables that you want to go into how much money you make after each mission, and then see the graph right here. Of course, you need to know a bit of maths, but I think it wasn't too complicated what we did today. And there are, of course, other possibilities as well, how to make this even more precisely, because here we made a few estimates, but with a few tricks you could get this even more precise. So I hope you enjoyed this video. Leave a like if you did so, and leave a comment below on what other things you want to learn next. And with that I say goodbye.